Alright, so continuing on with Chapter 1, Section 5. Here's a problem, and we want to find out, is there a solution? So the first thing we got to do is just simplify this thing. It's looking a little bit messy, so let's clear some stuff up and see what we can do using PEMDAS, right? So it's a quick review of PEMDAS while we're at it. Alright, so first thing we want to do is some parentheses. And we can do these just separately, one side at a time. So we can do this parentheses, and then we'll have q plus negative 8 times 4, right? Times 4. This is a times in here, right? There's a multiplication there implied with that parentheses. Oh, there seems to be an extra parentheses here. We don't need that. Okay, and so 3 plus negative 2 is just 1. So just 1 times 1. And let's go ahead and do the other side too while we're at it, the parentheses, the P in PEMDAS. So we're left with negative 8, and then 7 minus 4, 7, 6, 5, 4, 3, right? 7 plus a negative 4, difference sign, take the difference, okay? So we've got a positive 3, because that 7 group is bigger than that negative 4 group. Okay, and let's keep going. So let's go ahead and do the next line on this side. Well, that times 1, we don't even have to worry about that. Let's just forget about that. But a negative 8, negative times a positive is a negative, so that we have q plus a negative number. What is that? 8 times 4, 32. Okay, equals. And negative times a positive here, negative times a positive here is going to give us 8 times 3, that's negative 24. Okay, so we've got negative, let's rewrite that so it's nice and clear, negative 30, oh, that wasn't so clear, negative 32, right? On this side we'll q plus that, equals negative 24. Negative 24. Okay, well my question to you is there a solution for this? What I mean by is there a solution, is there something I can make, some number, is there some, and here we'll go back to section 1-1, right? Where let's think about this in words, right? And I actually maybe help us visualize this thing. Is there some number plus negative 32 to equal negative 24? Okay, well, negative 32, we can find a number, right? We can find a number to add to negative 32 to drop it down to 24, right? Think of it this way. So there is going to be a solution. How many? How many solutions? Well, there's going to be exactly one number we can add, right? There's exactly one number we can add to 32. And what is that number? Well, think about it like this. 24. Over here, right? Take the difference here, and let's see what we have here. So this is going to be a 2. That's going to be 12. 8, right? So 8. And I did this like the actual way that you guys will end up doing it using algebra, right? Adding the applying the inverse operation, blah 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 blah. We'll get there later. But really, we just think about this and say, okay, well, if I add positive 8 plus a negative 32, we get negative 24, right? So Q, oh, that's a G. Q is equal to the solution set, right? Solution set, right? And more fancy terms, but don't worry. Q has a solution of 8. To make this, so this would be our solution set, right? Solution set, and our set only has one element. That's the number 8. All right, and that's the number that we can put in as Q to make this statement. I'll put this in another color. To make this statement here, to make this statement true. So my solution set is just what numbers can I put in here to make this statement true. Okay, and in this case we have 8. Okay, so let's try another problem. Here we go. Here's a problem, and now we've got some stuff on both sides of the equation. That's totally fine. I've got variables. I got v on both sides, but let's try to simplify it out first a little bit. So take our parentheses first. Let's do stuff inside the parentheses right here. And let's see, so you can do multiplication or division in any order. I'll do my division first. That's 6 divided by 2 is 3. So this ends up being 3 times 3. So that's 9. I'll just go ahead and do that in one go. And then that is times v over here plus 10 equals 3 squared. I'll do that before I do anything else. I'll do my 3 squared, because that's an exponent that comes after parentheses, right? So that's 9. Oh, sorry, let me use the right color. 9. Okay, 9 times v plus 9. Plus 9. Okay, so what I want to ask is, does this have a solution? Does this have a solution? Well, notice I've got 9v on both sides. I've got 9v on both sides here. So this is 9v, right, and 9v here. Plus 10 over here, plus 9 over here. So remember, when we're looking at equations, the kind of most basic way of visualizing this thing is to think about a scale, like a little scale here, or a balance beam, the fulcrum in the middle. All right, and we've got 10 things over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got the same 10 over, or no, we've got 9 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got more here. There's 10 here. There's 9 here. We've got more on the left side, right? We've got more, so I'll circle that. There's more here. I'll try to make this look a little smaller. Maybe this side's a little bit bigger, one bigger than the right, right? And then we have this 9v. Okay, so that's the next question, 9v. What is that doing to our balance in our equation? Well, 9v is on both sides. So let's just say 9v is some quantity, right? At any given point, no matter what v is, 9 times v, no matter how you slice it, is 9 times v. So it's going to be this 9v is exactly the same as this 9v at all times. So let's just create some drawing for it. So 9v is going to be this like really crazy boulder, like looks like this. It's a big thing maybe. So that's 9v. All right, let me make it red too, actually, so that it correlates nicely here. I think the colors are kind of helpful. Let's see. So there's a big thing, 9v, right? And there's the same. Try to draw the same thing. It's not that close, but 9v. It's the same boulder-looking thing, all right? So that's here. This 9v boulder is also here, right? And also here. 9v. So those are exactly the same. Now, what do we have? We have, let me erase this down here now. So we've got 9v, this boulder thing, and we have for the left side, we've got the 9v boulder, and we've got 10 things. Okay, and on the right side, we've got the 9v, the same thing, and the 9 things. So what do we end up actually having? Well, the 9v weighs the same. If you think about weights and things like this, it weighs exactly the same as this. So we really, when you boil it down, we've got 10 and 9, right? Is what's trying to keep our scale balanced, right? Those two things are kind of fighting to balance out. And it turns out, right, these are not the same, so it's not going to be equal. What's going to be, heavier if you look at it this way? We're going to end up like this. Our 10 and our 9 is here, right? Because 10's a little heavier, maybe if we're thinking weights. And then we have our 9v, which is the same exact weight. So our 9v is still there on both sides. Maybe this will help you see how this 9v is not mattering so much, right? And really it's coming down to this 10, and 9. So is 10 equal to 9? Does this scale balance? Well, unfortunately not. 10 is not equal to 9. So there is no solution. Because again, go back to what is the solution? Well, the question I'm asking is there some v I can use that will make this scale balance out? Is there some v I can use? Well, no matter what I put in v, this quantity, 9 times that number, and 9 times that exact same number on this side are equaling each other. So they're in balance. This is balanced with this at all times if we're ignoring these two guys. But then we aren't always ignoring. We're checking. All right, well, 9 is not balanced with 10. So the fact is, no matter what we put in for v, we don't have a solution. And hopefully that was helpful.